we're going to see right now how to apply the flattening operation and the dense layer into a convolutional neural network with Keras. Hi, welcome to this new video. I'm Sergio, I'm a computer vision consultant, developer, and course instructor, and I help companies, freelancers, and students to easily and efficiently build computer vision software. We're now going to see the dense layer and the flattening operation just to give you an idea on where we apply this information. I'm taking like the structure of the VGG16 classification model. That is one of the first classification models that are popular. We'll see also this more in depth, but for the moment, let's just focus on the structure. So these right here are all the layers that make this model. We have convolutional layers. You already saw that in the previous lessons. We have the pooling operation, again, convolutional layer, again, pooling, convolution, pooling, convolution, pooling. After a lot of convolutional layers and pooling layers stacked on top of each other, at the end, we have the dense layer. The dense layer, fully connected layer, where the final goal is to bring a full an image to a very small information. So if let's say to give you an example, a real example, if we want to understand if on an image there is a cat or a dog, and we want to bring this lot of numbers, which is the image, to a very small number, we can say that the cat will be 0 and the dog will be 1. When after all these operations right here we will get to 0, it means that, or at least close to 0, it means that there is a cat on the image. If we get closer to 1, it means that it's a dog. I know that it might be hard to understand, but we will get through that. So just follow along, and we will also see now how to apply the dense layer, and later in also other videos, everything will be clear. Also, I want to let you know that if you are just a beginner, you know nothing about computer vision, or even if you are a developer, so you already know programming pretty well, that you work in other fields than computer vision, but you are a developer, I have a crash course down. It's called Computer Vision Blueprint, where you're going to learn how to detect and track any object in the most efficient and fastest way. It's a 1-hour workshop where I explain how to start from computer vision to get and build real projects, which is very useful if you want whether to build a project for your startup or for some clients and so on. pysource.com/blueprint down below in the description. And now we go right away with Keras. So I have the code right here, which is, there is no code because we have to write the code right now. As usual, we're starting with the dog.jpg image. Probably you have this image already from the previous videos. If you don't have that, you can download everything. There will be another link below. It will be a blog post where I'm going to summarize everything that we talk about today, and where you can download the full source code that I'm writing right now. We start by importing CV2, which is OpenCV that we will use to load the image. And I'm going fast right now because you should already know these first few parts. CV2.im read to read the image, and we're going to load dog.jpg. Now, to make sure that we're loading the image correctly, let's display the image on the screen. CV2.im show, we say EMG, so the name of the window EMG. And what do we want to display? We want to display EMG. Now a CV2 wait key event to keep the image on hold, wait key 0, and let's run this one. So I have the image is this one. Let's now go and create a model with Keras. So what do? We're going to import Keras. And by the way, even if you already know this part, I recommend to write everything from scratch. Repetition is always good to master anything. So just write what I'm doing. As simple as that. Don't copy and paste. Now we import Keras. Let's create a model. Model right here, and then model equals Keras.sequential. Keras.sequential. Now we're going to add the layers to this model. So we can say model.add. Now we need to import all the different types of layers. So from Keras we import layers. We import layers, and then Model.add, we're going to add layers. First, you should know what we add. What is the first layer into a convolutional neural network is the convolutional layer. So we add layers conv2d, and we're going to give a few parameters. The first one is input shape, which is the shape of our image, input shape, and we say 224. No, let's make this very small because I want to use a little information. Let's say 32 and 32, which we can also define like EMG size. EMG size equals 32, and then EMG size, let's make it this way, EMG size, because I say I'm confusing a bit, because normally the EMG size is width and height. So in this case could be 32 by 32 or whatever, 1000 by 500. But in this case we also need to say how many channels does the image have. The image has 3 channels because each color image has a BGR format. Blue, green and red stacked on top of each other give us the color, so that's why we say we keep it this way. Image size with 3 channels. Then input shape. After input shape, what else do we have? We have the filters, let's say 64, and then kernel size, which should be here, kernel size 3 by 3, and let's close everything. What do we have after the convolutional layer? Let's put now a max pooling operation. Model.add layers dot max layers dot max pooling to the pool size. This was already explained in the previous lesson, so if you are not able to follow along, it means that you skipped the previous lesson. If anything is difficult, go back to the beginning of the video series, link down below in the blog somewhere about all the series. Pool size 2 by 2 and strides 1 and 1, like this, or 2 and let's leave this. Let's leave it this way. Now we're at the moment where we show everything at this moment, but now let's print. Now we're not doing anything graphical. Let's just print whatever we have right now. We are going to print. Oh, okay. First, we need to give the output of the model. So we resize the image, EMG equals cv2.resize. We make the image of size 32 by 32. So what do we want to resize? We want to resize EMG. What is the image size? It's EMG size. This is the width and this is the height, 32 by 32. We want to get the result of this model. So we are going to pass the image inside the model. Result equals to model.predict, and we want to predict after we pass the image in size. Array np.array, and we pass EMG. Of course, we need to import numpy as np, import numpy as np, and let's print now the result. Print result. And I got a typo because there is some error right here. I know already the error. So model.predict, what do we want to predict? np.array, and then we put the EMG into brackets. Why do we put the EMG into brackets? Because we can do this operation with multiple images at once. So this is just the first image. We could put EMG1, EMG2, and so on inside the brackets. So EMG is into an array. So let's run this again. This is what we've got so far. We have a lot of numbers, which in the previous image I show you like the features each image for all these numbers. What we want to understand now is how can we transform these features, these images, into just numbers. Now we're going to do 2 operations in sequence. The first one is the flattening operation, which will make sense by displaying the structure first. So these numbers right here they have this structure. So if I print result.shape, let's run result.shape, we have a structure of 1, 29, 29, 64. So let's let's save somewhere this structure. So I'm going to take Notepad, I'm going to copy this one, 129.29.64. Let's now apply the flattening operation. After max pooling, we say model.add layers.flatten. That's it. That's the only thing that we have to do right now, and then we can run this one and display again result.shape. And now we have 33,824. 33,824. And you will see that if we use the calculator, so let me open this one, we have, if we multiply 29 by 29, so 29 with 64, we have 53,824. The flattening operation is like the just English translation, making something flatten something. So if we have a lot of images, we are going to put them together, so the number one after each other into just one single row. So that's what the flattening operation is doing. To give you an example with simulating an image, I will now simulate a very simple image of 3 by 3 pixels. So let's say that this is the array to make an image with 3 pixels. Let's say that the value 0 is black and the 1 is white. So let's just draw a white line. So 0, 1, 0, 0, 1, 0, 0, 1, 0. So there is an image with 9 pixels where the 0 is white, the 0 is black and the 1 is white, and we are drawing a vertical white line. When we apply, and of course this has 3 by 3, so 3 rows and 3 columns, when we apply the flattening operation, this exact array right here will be converted into this 0, 1, 0, without the comma, 0, 1, 0, 0, 1, 0. So instead of having an array with size 3 by 3, we have one with size of 9, just one row of 9. So we're doing the same exact operation after we get all the features from the max pooling. Right here we're doing the same operation, of course with a huge amount, with a much bigger number than just 3 pixels that we have right here. Of course we will not get 53,000 normally, because when you see the layers, so the VGG architecture is going to shrink the information so much that at the end we will have a small amount of information. Because if you had like 53,000 parameters just at the end and you have like huge amount of parameters, of course it will take very long to process, and the less parameters we have, the better. To give you an idea, this is the structure that it's done usually with the classification model. I just found some other classification model, just researching on ResearchGate. This is the standard structure. So input image, convolutional layers, pooling layer, then we make it in the flattening operation, and then the dense layer. Let's now get into the dense layer. So this is the flattening operation. It should be clear. Let's print this information so that it will even make more sense. So we have result.shape. Let's print also the result. Print a result, and let's run right now this one. So we have in one single row right here all the numbers. Of course, these dots is because we cannot display all of them, but in these middle dots we have like 53,000 plus numbers in just one row. Now we're going to apply the dense layer. So the dense layer works this way: model.add layers.dense, and let's say units, let's just use 10 of them. The dense layers are usually represented by representing neurons. It's probably the most common image that you have seen when you think about deep learning and neural networks. So let me display that. So the dense layer is fully connected layers this way. We have 1, 2, 3, 4, 5. So let's say that this is one layer with 5 dense units. It could be better draw, but I could make a straight line, but it doesn't matter. So let's add other 3. So let's say that this is a dense layer with 5, this is a dense layer with 3, and they are all connected one with the other. So there is a full connection of all of them. So all of the first layer with the second one, then this one right here. Like, you get the point. Like, they are all fully connected layer. And the purpose of this is to bring still down the information to have just at the end, like, we need just to have just a value that tells either whether there is this object or not in the image. So that's the goal, to bring down simplified ways the information. Let's now to play around with the dense layer in this specific case with this image, with this model right here. Now I'm adding 10 units of dense layer right here. Let's now make a prediction with this. So we are dense layer with 10 units. Let's now run the result. So we run dense layer. You can see right now that we get as final result just 10 numbers, so 10 values. So if we put 10 units, we just get 10 values, which are just numbers, which for now these numbers don't really make sense. But let's now understand like what's happening with these 10 units. So how are these 10 units connected with the flattening layer? These 10 units are connected with the 53,000 plus values that we are getting. So we have 53,824 values that we are getting connecting with these 10 units. If we had to represent this, so of course I will not draw all of them, just to give an example, we are getting from the max pooling flattening layer, we're getting 53,000 plus values. You need to consider like all of them. So we have like 53,000 plus of them. Every one of them, each value is fully connected with the latest 10 units. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, I have the space for them. So you need to consider huge amounts of connections right here. And of course, we will not have 53,000 now. It's because it's just a terrible model. They wanted to draw with just few layers that will not work very well, like keeping them this way. We need to have less than 53,000. We will understand better when we build a real model from scratch how to play around with the values, but it's just for you to get the idea. So keep in mind all the 53,000 values connected with these 10 new units. And among each value, so this 53,000 will be multiplied with the first unit, with the weights of the first unit, and we will get this value right here. The second unit, so 53,800, I don't even remember, 53,824 with the second unit, they give us this number, and so on. If you want to know more about how a dense layer works and how it works from scratch, I have another video series which I'm going to link, and it's on YouTube. So I'm now going to quickly show it's a video series of 7 videos about neural networks from scratch, where I show like how to create a neuron completely from zero with just Python. We'll make some manual operation so that you understand what each unit is doing with the values and how they are multiplicated. So if you want to get more in depth, there is this video series. It's I put this on YouTube, and I will put also down the link on the blog post. So if you want, you access the blog post, you will see everything that you need to understand more about the dense layer and the operation with the dense layer and the other layers. So this is pretty much what the flattening operation does. Then we have the dense layer. The dense layer can have all other parameters like the different types of activation functions, which will work differently based. We can change the activation functions for various reasons. We will see that in another video. For the moment, it's good that you play around with this, and you will grasp slowly. You will grasp how a convolutional neural network works. If you have any question, just let me know down below in the comment section. This is all for this video. See you in the next one.